So this is a ballistic pendulum. You just saw a video of a ballistic pendulum, hopefully before. It didn't stick, but this example, it does stick. So we shoot the bullet, it hits some piece of wood, shoots the bullet from here, it hits like some piece of wood or something, it sticks to it, and then that pendulum and the bullet swing up. And if we measure the height, the initial height from the final height, that's going to give us some information. So the band is playing at school today, so you might hear the band in the background of this video. Okay, so we have a 0.02 kilogram bullet. The pendulum is 5.5 kilograms. It sticks together, and there's a maximum height of 0.36. Determine the velocity. Okay, so first, let's look at conservation of energy. So kinetic energy, the energy of motion, is going to be converted into potential energy, or the energy of position. So looking on our formula sheet, EK is 1/2 mv squared, and potential energy is mg height. That's a g. Mass, gravity, height, acceleration due to gravity. Okay, there's mass on both sides, so if we divide by mass, it gets rid of the mass. We have 1/2 v squared equals gh. Getting speed by itself, we times both sides by 2, and then we would square root both sides. So now we're just putting in the values that we know. 2, gravitational acceleration due to gravity is 9.80. The height is 0.386. That was from the question. 0.36. I didn't type my question right. That's my problem. The example I have in front of me is 386. Okay, and now we're going to need a calculator. So we need the square root of 2 times 9.8 times 0.386, and the square root of 0.75656 is 2.75. So my velocity is 2.75 meters per second. Okay, this is the velocity of the pendulum right after the collision has happened. Now we have enough information to use conservation of momentum to examine before and after the collision, which allows us to calculate the velocity of the bullet just before it hit the pendulum. This is what conservation of momentum is good at, looking at both before and after the collision. Okay, so momentum total before equals the total momentum afterwards. Okay, so MP so we have both of the pendulum and the bullet is what's happening here. The mass of the pendulum, velocity of the pendulum, mass of the bullet, velocity of the bullet equals mass of the bullet, velocity of the pendulum after, plus mass of the bullet. Sorry, this is pendulum. Mass of the bullet, velocity of the bullet afterwards. Now, these two stuck together, so we're going to put MP plus MB together, and they're going to be going that same speed. Okay. The mass of the pendulum and the velocity of the pendulum, at the beginning, there's no velocity of pendulum. It's 0. 0 times anything is 0. So we just have MB, mass of the bullet, velocity of the bullet. Okay. We know the mass of the bullet is 0.0200. Velocity of the bullet before is what we're trying to find out. Over here we have 5.75 plus 0.02, those two masses added together, and my velocity we just calculated was 275 meters per second. This is kilograms. This is kilograms. Solving for the velocity of the bullet, then we are going to divide both sides by 0.02 kilograms. Um, and we should have 15.9 kilogram meters per second squared when we calculate this side. Kilograms get canceled out. We're left just with meters per second, which kind of makes sense if we're talking about the velocity. So when I do this calculation, I got 794 meters per second. So you want to pause, grab your calculator, and make sure you get that answer as well. So the bullet was traveling at 794 meters per second just before it hit the pendulum. Okay, so we did this in two steps. First of all, we looked at the conservation of energy. Then we looked at the conservation of momentum. Okay, so there was kind of two parts. Conservation of energy. That's why we used this concept right here. And then we did the conservation of velocity, or of momentum. So two steps that we did in this question.